In this video, we're going to do an exam question walkthrough of the 2015 question that came up on stoichiometry. So these are all the calculations. Now, the way we're going to do this is the way we usually do it. We're initially going to give you a chance to do each part all by yourself. And then if you can't manage it, we are going to support you by giving you some hints or support or tips. But it's always best, guys, to pause the video and have a go by yourself first, because you need to get to the stage where you don't need the support. So no problem if you need a little bit of support, but as you practice more of this type of question, you should be getting to the stage where you can do them by yourself. All right, so it's worth 25 marks. So what we need to do is set a timer for 10 minutes. That's what you have. And we're going to jump into it now. Set your timer. All right, let's read the blurb. It says silicon dioxide reacts vigorously. This just means violently or very quickly, very quick. So lots of gas, lots of noise maybe, with magnesium powder to form magnesium silicide, a dark blue solid. I don't think that's important, but maybe we'll come back to it later. When magnesium silicide dissolves in hydrochloric acid, the silane gas produced ignites spontaneously. And what this means is it just basically catches fire all by itself when it comes into contact with oxygen in the air. The balanced equations for these reactions are given below. So you see here we have three equations. This is number 1, this is number 2, and this is number 3. Okay, so three separate things. So first of all, this is silicon dioxide reacting with magnesium. Then we have magnesium silicide, which was produced here, reacting with HCl, producing SiH4, which will then have SiH4 reacting a third time where it comes into contact with oxygen. It reacts spontaneously, so by itself it catches fire and it produces these two products in reaction number 3. Okay, so let's jump in. Let's start tackling the problem now. We're going to jump into part 1. First of all, it says, what is meant by a mole of a substance? So this is a very straightforward definition. Again, what are definitions in chemistry? They are not your opinion. They are very specific facts, and they have to be written about in very specific ways. So there's no other way around this other than you guys should be practicing learning these. Now, my students use an app called Carousel to make sure that they are practicing this vocabulary, so using flashcards and then quizzing themselves. So it's very important that you, if you're not in my class, that you have some system to learn your definitions. So hopefully you can pause the video and define the mole now. Pause the video. Okay, so if you're not able to, I'm going to help you start it off. So first of all, what is an amount, or what is a mole? A mole is just an amount of a substance. It's amount of a substance. I'm just going to make this pen a bit smaller. Apologies. So it's amount of a substance, and it can be any substance, of a substance, which contains, now it contains a very specific number of things. So it could be, we could have a mole of eggs, you could have a mole of potassium hydroxide, you could have a mole of oxygen, but it contains a very specific number of things. So can you pause the video if you weren't already able to? Pause the video, write this down and finish it off. What does it contain? Okay, so what you should have done is written down a number here, an amount, a quantity. That number is 6.02 by 10 to the power of 23. So it contains 6.02 by 10 to the power of 23, and it's particles. Now, those particles can be anything. They can be oxygen particles, they can be hydrochloric acid particles, they could be sodium chloride particles, they could be helium atoms. It doesn't matter. That's why we use the word particles. But this here is the key bit. This is, a mole is this number of things. So it's amount of a substance which contains 6.02 by 10 to the 23 particles. All right, let's jump on to the second bit. All right, that's done, dealt with 6 marks in the bag. Easy definitions, but only easy if you practice them and you know them. All right, let's look at the second bit. It says, how many moles of magnesium react with silicon dioxide to produce 7.6 grams of magnesium silicide? All right, the first thing I want you to do is I want you to pause the video. In a second, I'm going to write down part 2. I want you to pause the video and tell me which of these 3 equations, 1, 2, or 3, is this part 2 referring to. Pause the video and write that down now. All right, so hopefully you said that it's chemical reaction number 1. And we know this because we have magnesium, which is here, reacting with silicon dioxide, which is here, to produce magnesium silicide, which is here. And what we want to know is how many moles, so our answer needs to be in moles. Okay, how many moles of magnesium react with silicon dioxide to produce that much, 7.6 grams magnesium silicide. If you know how to do this, pause the video and do that calculation now. Okay, so hopefully you were able to have a go at it. If you weren't able to have a go at it, I'm going to help you plan out the conversions that you need to do here. Okay, so what conversions are we going between here? The first thing that we're going to do is we're going to go from grams of magnesium Mg2Si, sorry, grams of magnesium silicide, because that's what we started with, 7.6 grams of magnesium silicide, which is this here, magnesium silicide. And we're going to convert, before we can do anything, we always have to go to moles. So we're going to go to moles of magnesium silicide, Mg2Si. So this is conversion 1. Once we have that, then we can go from moles of Mg2Si to moles of Mg, which is what we want our answer to be in. This here is our answer. Okay, so let's double check that that is our answer. Yeah, how many moles of magnesium? All right, so what we're going to do is I'm going to leave this up so you can see the numbers. I'm going to zoom out so you can see the conversions over here. I'm going to get to pause the video and have a go at this now if you haven't done it already. Now, okay, so you should only be having a look if you have done this. Now, I have, there's a couple of ways you can do this, but the way I recommend is the way I always do it now, is I do something called a unit conversion, where I set up the units before I put in any numbers, and we find out how we're going to convert it. So we're going to begin by writing down what we started with. We start with grams of magnesium MgSi, and we're converting to moles of MgSi. Now we do this using a fraction. This is called a conversion factor, where we put the two things we want to go between. Now we want to go between grams of magnesium silicide to moles of magnesium silicide. Now, when I'm setting up my unit analysis, I always want to make sure that I'm left with the units that I need in my answer. So to do that, I'm going to put grams of MgSi in the bottom, in the denominator of my fraction. So it cancels with those grams of magnesium silicide. So see, them two units are the same. So what we're essentially doing here is dividing grams of Mg2Si by grams of Mg2Si. Okay, if you don't believe me, this is how this works. This is really this here. Okay, so we've got two numerators and one denominator. So now we've got Mg2Si on the top, Mg2Si on the bottom, those cancel. And that leaves us on the top is the other unit that we want to relate it to is moles of Mg2Si. And this is what we're left with, and that's what we needed in our answer to part 1. All right, so the next thing we're going to do is we're going to write down the numbers that we need. So go ahead, if you don't know already, pause the video and put the numbers in. I'll show you the question again. There we go. Pause the video, do that now. Okay, so the way you should have done this is we should have said, okay, what we're starting with is we're starting with 7.6 grams of Mg2Si. And the next thing we want to know is that for every 1 mole of Mg2Si, how much grams is that of Mg2Si? And the answer is, well, it's the molar mass of that substance. So 1 mole of any substance is the molar mass in grams. Okay, so how do we get the molar mass or the MR of this substance? Pause the video and work that out if you didn't do it already. Okay, so first of all, what we need to do is we need to do 2 magnesium. So we've got Mg2 here. So this is 24 is the mass of magnesium times 2. And then we're going to add to this the mass of silicon, which is 28. Where do I get these masses? I get these masses on a periodic table. Just as an aside, how much is that if we were to work it out? It actually works out as 76. So that sum there is 76. So it's 1 over 76. Pause the video and calculate that now. All right, what you should have gotten here is you should have got 0.1 mole. And what's the unit that was left? This one is the only unit that's left. So this is 0.1 moles of Mg2Si. There's part 1 done. I'm going to speed it up now, guys. We're going to take this answer, moles of Mg2Si. I'm going to take that moles and we're going to go to moles of Mg. Now, I'm going to get you guys, if you know how to do this, I'm going to zoom out so you can see the equation. You're going to pause the video and have a go at this now. Do that right now. All right, so this is part 1 done. Okay, this is the first conversion done. And we're going to move on to the second conversion now. Okay, I'm going to set up a unit analysis again. You can't go wrong if you do this by unit analysis. So we're going from moles of Mg2Si times by, we've got a conversion factor to set up. And I'm going to link together the two things I want to go between. I want to go between Mg2Si, moles of Mg2Si to moles of Mg. So pause the video and write down which one should be on the top, which one should be on the bottom. Okay, so I've got moles of Mg2Si on the bottom, and they cancel with N. And then we've got moles of Mg left on the top, and that's what I want to be in my answer. Look here. All right. So now we need to fill in the numbers. We've got the unit analysis done. We're going to fill in the numbers. So remember, this is the amount of moles of Mg2Si I had. Sorry, I don't need to write that. It's 0.1. That's what I worked out before. And the next thing I need to know is, well, how many moles of magnesium is there for every mole of Mg2Si? So I'm going to go over here and we're going to look at the balanced equation. So here we can see our molar ratio. Pause the video, write down the molar ratio if you haven't done this already. So this is 1:4, 1:2. So this is Mg2Si and this is magnesium. So 1 Mg2Si for every 4 magnesiums. So go back over here and I'm going to put 1 Mg2Si for every 4 magnesiums. Pause the video and do this sum now. Right, what you should get is 0.4. And what's the only unit left? It's moles of Mg. Moles of Mg. Now, I'm going very slow here, guys. When you learn how to do this, this will be really quick. And it's a really nice way of doing it. It's very hard to go wrong when you use the units. All right, on to number 3. Okay, so now that I've shown you how to do that, we'll have a look at number 3. It says calculate the number of moles of hydrogen chloride, HCl, required to react with 7.6 grams of magnesium silicide. What mass of magnesium chloride is produced? So there's 2 parts. I'm going to break this into 2 parts. I'm going to say this is part 1 and this is part 2 because it's very easy to forget this part. Okay. So first of all, calculate the number of moles. So this is the answer to your first part is going to be in moles. And then you need to find the mass. So the answer to the second part is going to be in mass. All right, so what we're going to do is we are going to pause the video, and if you know how to do this, go ahead and do it. I advise you use unit analysis to do this. Okay, so let's help you through this. Okay, if you weren't able to do this, let's help think about the conversions that are going to be involved here. All right, so let me just have a think here. This is part 1, 2, 3. Now, first of all, we've already dealt with 7.6 grams of magnesium silicide in the first question. Here, we found out how many moles that was. Okay, so moles of magnesium silicide is what we already worked out up here. So we don't need to do this again. We've already got that 7.6 grams of magnesium silicide is 0.1 moles of magnesium silicide. So use that to your advantage. Don't waste your time doing it again. So here we're going to go from moles of Mg2Si, and we need to go to, what does it say? Calculate the number of moles of hydrogen gas. So we're going to go to moles. No, not hydrogen gas. It's hydrogen chloride, moles of HCl. Okay, I'm going to put back the equations for you so you can see. Pause the video and do that conversion now if you didn't know how to do it. All right, so now that I've helped you plan it out, go ahead and do this. This is what you should have done, setting up unit analysis. We've got a certain amount of moles of Mg2Si, and we're going to set up a conversion where, we're going to go and we're going to set up our conversion where we're going to go, we're going to convert to moles of HCl. So we want to put moles of Mg2Si on the bottom, so it cancels with those. And we're going to leave it with moles of HCl on top so that we're getting the unit that we want in our answer. Okay, so now we put in the numbers. You've got the unit analysis done. We're now going to put in the numbers. Okay, so first of all, we had this many moles of Mg2Si, so 0.1 moles of that. And we go to our equation, and we want to use the second equation this time to find out how many moles of Mg2Si is there for every mole of hydrogen chloride, or so on. So what's the ratio here? Okay, hopefully you're seeing that for every 1 mole of Mg2Si, it's 4 moles of HCl. So again, I'm going to pause the video and write down how many moles of HCl is that. Okay, 0.4 moles of HCl is the answer. Same as actually before, except it's different. It's moles of a different substance this time. So that is part 1 of part 3, but don't forget this. This is critical. This is part 2 of part 3, if you like. What mass of magnesium chloride is produced? So here is magnesium chloride. All right, so if you know how to do this, pause the video and have a go at it now. All right, so again, if you don't know how to do this, we need to think about the conversions. We already know we've got 0.1 mole of this substance. We already know that, and we've already converted to how many moles of that there is. This time we want to go to how many moles of that there is, and then convert to how many grams of that there is. Okay, so let's think about the conversions we got to do here. We've got to go from, again, if you know how to do this, pause it and do it now before I help you. Okay, and if you didn't know how to do it, here's a little bit of help. We're going to go from moles of Mg2Si to moles of MgCl2. That's our first conversion. And then we're going to go from moles of MgCl2 to grams of MgCl2. So 2 steps in this. All right, so call this right, so we've already learned that we've got 0.1 mole of Mg2Si. Again, always go back and check to make sure you're right. We're going to convert, so we're going to set up a unit analysis conversion where we go from mole of Mg2Si on the bottom to moles of MgCl2 on the top, moles of MgCl2. Those cancel here, moles of MgSi2, or Mg2Si, sorry, gets confusing with all the symbols. And now we need to look at the relationship between these two things in the equation. So go back up here. What do I see? I see that we've got 1 of these for every 2 of these. I'll go back and put that into my equation. It's going to be 2 of these for 1 of these. Okay, pause the video and work out how many moles that is. Okay, so very quickly, you should have got 0.2 moles of MgCl2. Now that wasn't your final answer because you were then asked to find the grams of MgCl2. So we're going to take that number of moles and convert to grams. Now pause the video if you know how to do this. Okay, if you didn't know how to do this, you really should by now. I think we've practiced enough of these. We're going to use a unit analysis conversion again, where we're going to go from moles of MgCl2 to grams of MgCl2. Okay, moles of MgCl2 cancels out and leaves us with grams of MgCl2. Now we're going to pause the video and you are going to write down, how many grams is there for every mole. Pause the video, do that now. All right, so what we should have done is we should have done for every 1 mole of MgCl2, there are a certain amount of grams. How many grams is that? Well, that's the MR expressed in grams. So we have 1 magnesium, 1 Mg, and we have 2 times Cl. We have 1 magnesium and 2 chlorines. So adding up the masses of those, we get 24 plus, so this is all a sum, 24 plus 2 times the mass of chlorine, which is 35.5. So what we're going to do is go ahead and put that into a calculator now. Okay, so and probably a good idea to do this in brackets. And that gives me 19. So if you got 19, well done. And what are the units? It's grams of MgCl2. Grams of MgCl2. Right, so really unit analysis is the best way of doing this because you always know that you got it right. What unit were we left with here? Grams of MgCl2. And that's what we wanted on our answer. Look, it said what mass of magnesium chloride, which is MgCl2, is produced. So it's impossible to kind of go wrong here, really, if you use unit analysis properly. Right, last step, part 4. What volume of oxygen gas measured at room temperature and pressure? Okay, so what I want you to do is pause the video and tell me what's the conversion between moles and liters at room temperature and pressure. Pause the video and do that now on a bit of rough wet paper. Okay, so what you should have said is at room temperature and pressure, there are 24 liters for 1 mole. Or it's also true to say there is 1 mole in every 24 liters. So both of those are true. So you can split them up and down and use them at top and the bottom. All right, so what volume of oxygen gas measured at room temperature and pressure is required for the complete combustion of the silane produced from 7.6 grams of magnesium silicide? All right, So if you can feel like you can tackle that, go ahead, pause the video and do that now. All right, so if you didn't feel like you can tackle it, I'm going to again walk you through the conversions. The first thing we know is we've got 7.6 grams of magnesium silicide, which we already know and we've worked out that 0.1 mole. So don't do that again. We already know we've got 0.1 mole. So this time we're going to go from mole of Mg2Si. And we need to first go and find out how much silane that produced, which is SiH4. So we need to look at the second equation. I'm going to rub this out and we're going to find out how many moles of silane. So going to moles of SiH4. That's the first step. The second step then is to go from moles of SiH4. We want to find out how many moles of oxygen have to react with that. Moles of O2. And then finally, there's a third conversion. Once we get the moles of O2, we want to find out how many liters of O2 is that at room temperature. All right, pause the video and work your way through those three conversions. Make sure you get liters of O2 as your final answer. All right, let's have a look at these three conversions then. Okay, so if you didn't know how to set it up, we're going to set up the unit analysis for you. We're starting with moles of Mg2Si, and we're converting to, we want the same on the bottom, moles of Mg2Si. They will cancel for us. And we want to leave us with moles of SiH4. All right, so we started with 0.1 moles because that's what 7.6 grams is. We calculated that earlier. And looking at our equation, we can find out the ratio. We can find out that, where are we? Moles of SiH4 to moles of Mg2Si. Well, it's a 1-to-1 ratio. Okay, so that's going to be 1 mole of SiH4 for 1 mole of MgSi2. So that's going to give us 0.1 moles of SiH4. Very simple, 1-to-1 ratio, so the same amount of moles. We're then going to take that, that's our part 1 is done. We're then going to, we have this as our start, and we're going to convert to moles of O2. So we're going to go ahead and we're going to, oh, actually, do you know what? I'm going to go on the second line and start that again. So 0.1 mole of SiH4. We'll do the second conversion on the separate line times by, and I want to convert between moles of SiH4 and moles of O2. Pause the video and put those units on the top and the bottom of this. All right, so you should have put moles of SiH4 on the bottom, and then they will cancel there with those. And we want to put moles of O2 on the top. All right, so the ratio here, if we look at this third equation, tells us that one of these reacts with 2 of these. So we'll go and put that into our fraction now. Pause the video and do that if you haven't already. All right, this is 1 for every 2 of these. Easy, which gives us 0.2 moles, and it has to be O2 because that's the unit that's left. The other one is crossed out. Good, that's the second one done. We're at moles of O2 now. We now want to go from moles of O2 to liters of O2. So I'm going to just continue this on over here. I want to set this up. I'm going to go between moles of O2 and liters of O2 at room temperature. So pause the video, and we're going to put moles of O2 and liters of O2. Make sure you put them on the correct, either in the numerator or the denominator here. Pause the video, do that now. Okay, what we should have done here is we should have moles of O2 on the bottom, so they cancel with that. And with liters of O2 at room temperature up here. So what's the rule? How many liters for every 1 mole? Pause the video, write that down. 24 liters for 1 mole. All right, let's go ahead and figure out, put that in our calculator, and we get liters of O2 in our answer. All right, you should have got 4.8 liters of O2. And we know we've done it right all the way to the end, because look what our answer is liters of O2, which is what we were asked for in the question just over here. What volume of oxygen gas? All right, that's it, guys. Pretty straightforward if you know how to do the unit analysis. It's not the only way of doing this. So long as you got the same answers as me the whole way down, then if your way works for you, fair enough. I find though that this system of unit analysis will work in pretty much any calculation in chemistry. So it's the best way of learning it. And it's kind of a first principles method, which means it uses fundamental maths. It doesn't use any formulas or tricks that you have to try and remember. It just is a process for actually doing maths and working stuff out. All right, guys, so that is 2015 question. I hope that you found this video useful. If you did, please drop a like in the please drop the video a like, because it might help other students who are struggling to find it. And the more people I can help, the better. That's what the channel is for. All right, guys, that's it. I will see you in the next one. Thanks for watching.